I'm going to explain about what's aerodynamics and why is it important in the rocket design and other automobile fields. Before we get into the topic, I want to discuss to you about the question that I have asked in the last video. Let me recap the question that I have asked. I told that to assume that this was a kite. In this kite, there is a rope that we are holding. And then how does this kite fly? The kite flies with the wind rushing upon the face. This face accepts the wind and propels forward. So, we know that every action has an opposite and equal reaction as per the third law of motion by Newton. So, we have the action here as air. If air here is the action, then what will be the reaction was the question given by me. So, the answer here is, instead of the reaction from around the kite, the reaction will be on the rope, meaning that the rope will be pulled from you. If you are standing here and you are holding the kite, and then the rope will be pulling. I hope you have experienced this phenomenon. This is where the reaction acts. Now, what is this aerodynamics? You can see this nose cone here. This nose cone has a sharp tip around here. This tip tears air apart. So why do we have these sharp tips or slanting aero things on cars also? These are known as for aerodynamical purpose. As you can see here, the nose cone's tip is here. This tip actually penetrates the air from around. As you can see here, you can see a rocket here, a basic small rocket which has a nose cone, a body tube and two side fins. In this, I'm going to explain about this top nose cone and these two side fins. Why are they important and why should they be there? If a space shuttle or a rocket is going to launch, it will face various difficulties like overcoming gravity, air resistance and drag. In this basic rocket is again three fins here, as you can see. So how does this aerodynamic way work? First, I'll talk about the air resistance. The air would be hitting on the rocket from the top. Now, I'll talk about the subject of air resistance. I hope you all have bought the thermocol papers, the thermocol sheets. When you're riding on a bike, you have the thermocol with you, and the thermocol's large surface area, which is this, is getting exposed to air which is acting from outside. Then the pressure will actually push the thermocol backside. I hope many people have experienced in this feeling. So this is what is called air resistance. When an air is acting on an object with a larger surface area, it will decrease the speed or the momentum in which the object travels in. In the same case of the rockets, so as you can see in this rocket, how does the air resistance work? The air comes from this way and goes like this, and because of the fins, again it travels again in the upper way. So there won't be any pressure on the top of it, meaning that the speed of the rocket will not decrease. So there will be an advantage. What would happen if the rocket was like this, without any nose cone, but only a booster and a fuel tank? Then what would happen is that the air will act on the body tube and will decrease the speed of the rocket from moving forward. So therefore, the speed will get decreased. But if we keep a nose cone like this, then the rocket and the air will not have any contact with them, meaning that there won't be any air resistance that will not make you propel forward. So now about the second factor. What is gravity? Gravity is the pull of an heavenly object. And all heavenly objects like our Earth, our Sun, and all the other planets in this cosmos and asteroids possess gravity. Gravity is the pull due to the North Pole and South Pole electromagnetic fields. These electromagnetic fields are spread across the world and on all the other planets. All planets have these electromagnetic fields, whether weak or strong. So, how does this electromagnetic field can be broken? I mean, not literally broken, but how can a rocket or any automobile escape from this grab? Our Earth's gravity pushes an object when a ball or any object is thrown from any height. So the speed or the velocity for per second is 9.8 meters per second square. So this is the total velocity that the object claims every second. So how to beat this velocity? If a rocket is launching upwards, it doesn't mean that it will have to propose only 9.8 meters per second velocity. It will also have to climb at a higher velocity. That is, so now, including the rocket and air resistance, the rocket has to climb up more than a speed of 11 meters per second square, which is the escape velocity from the Earth's atmosphere. So this is how the rocket will break apart from both the gravity constants and the air resistance. So what will happen without these air resistance and gravity holders, that is the nose cone and aerodynamical ways? The another important thing about these aerodynamical uses is that it will hold the rocket in a position. So in this rocket, as you already know, the air passes like this with the air resistance. Why would the fins be important? Without the fins, the air will be again plumbing onto the rocket instead of going away from it. With the fins, the rocket moves very swiftly, like you see in the arrows and bows. How's the arrow designed is just like a rocket, but with a thinner body. Let's assume this is an arrow. When you're shooting it out from the bow, then the arrow will go straight forward and will be aerodynamically positioned, and it will not move away from its target. This is the reason why we have fins on rockets. As you can see in this car, I'm going to talk about the automobile's aerodynamical position. So this is a race car. It also has to move swiftly and aerodynamically so that it can move faster than a normal car, which moves slowly because of the non-aerodynamical ways. So how does the aerodynamics in these cars and other automobiles work? The air comes like this, and the air moves like this and goes like this. So if it was a normal car, the air would push the car forward like this, and the car would not give a proper speed. This is the aerodynamical way and position for a rocket and a car to move propel forward. So now these side bars, as you can see here, is also for an aerodynamical purpose, so that whenever air comes like this, it should not hit the car and will go like this, so that there won't be any deceleration, which is anti-acceleration. Again, you can see here that there is another aerodynamical pathway for the air to rush in, so that, and there's another air leviation. In this leviation, the air will, this is also known as the air pockets, through which the air will go inside and also come outside and deviate the air from hitting the car again. This is the main purpose, that all the aerodynamical purposes is on the automobiles, racing automobiles, and etc. If you see normal cars in our neighborhood, there won't be much aerodynamical usage, so that there won't be any other purposes. Thank you.